Hello student, today we are going to see with the difference between linear motion and rotation motion. S is a linear displacement, theta is a angular displacement, V is a velocity, omega is a angular velocity, A is a acceleration, linear acceleration, alpha is a angular acceleration, U is the initial velocity of linear motion, omega naught is the initial velocity of rotation motion. Okay, this side is a linear motion, this side is rotation motion. Now S is a displacement. Displacement, the unit is going to be meter. Dimensional formula m power 0, L power 1, T power 0. In angular displacement, theta we can take it. Unit will be degree. Okay, 3 degree, 4 degree, 10 degree like that. Degree we can have radian. Okay, dimensional formula. There is no dimensional formula for angular displacement. Okay. Velocity, linear velocity is equal to displacement by time. Displacement is meter, time is second. Okay, dimension formula m power 0, L power 1, T power minus 1. Angular velocity is equal to angular displacement by time. Angular displacement radian, time period is second, radian second minus 1. Dimension formula m0, L0, only time is the T power minus 1. Radian we don't have dimensional formula. Okay. Now, linear velocity, linear acceleration, linear velocity by time, meter per second, second square. From denominator, if you are taken numerator, second minus 2. What about the dimensional formula for linear acceleration? m0 meter, L power 1, time power minus 2. Okay. Angular acceleration, radian by second square, radian second minus 2. m0, L0, T power minus 2, radian we don't have dimensional formula. Okay. Linear acceleration, this way also we can write. Okay. Like a 2-time differentiation. Okay. Angular acceleration, like this also we can write. Okay. Next thing, linear momentum, mass into velocity, we can have linear momentum. The unit of linear momentum kg, velocity is meter per second. Okay. So dimension formula, yeah, m power 1, L power 1, T power minus 1. For angular rotation motion, angular momentum is the linear momentum times of radius. So linear momentum already we know kg meter second minus 2. Radius will be meter. So meter square, kg meter square second minus 2. M power 1, L power 2, T power minus 2, dimensional formula for angular momentum. In linear motion, mass we can take it mass only. The unit of mass is kg, mass power 1, length is 0, time is 0. But in rotation motion, mass is not a mass, it becomes as a inertia. Okay, because all mass will be concentrated at center. So mass times of radius square, mass is kg, radius is meter, meter square we can have. Dimension formula m power 1, L power 2, T power 0. Okay, mass is 1 time, length is 2 time, time is there is no time. Okay. The next one, so this is a common relation. Okay, when we have circular motion, arc length by radius is equal to displacement, angular displacement. This is a formula. Arc length by radius is equal to theta. If you want theta, S by R, you can get the unit is in a radian. If you want proof, circumference of the circle is going to be 2 pi r by r get cancelled, 2 pi, 360 degree. Okay, so theta is equal to S by r, S is equal to theta times of r. Okay, this is what we can have. Okay, so differentiating this equation, what we can get? So velocity ds by dt, d theta by dt into radius, v is equal to omega times of r we can get, because this is velocity, linear velocity, angular velocity into radius. Okay, again we are differentiating, a is equal to alpha times of r we can get. Okay, so now finally we got s is equal to theta times of r, v is equal to omega times of r, a is equal to alpha r. Okay, in linear motion, force is equal to mass into acceleration. So for mass is kg, acceleration is meter second minus 2. M power 1, L power 2, T power minus 2, dimensional formula. Same in rotation motion, torque, force into perpendicular distance, Newton meter, Newton kg meter second minus 2 into meter, kg meter square second minus 2. Okay, so linear motion force, rotation motion we can have torque. Okay, so now torque, the another formula we can have I alpha also. Okay, because torque is equal to force into perpendicular distance, force is mass into acceleration. So mass, acceleration I know alpha times of r, alpha r. So r square, mr square we will have inertia. Torque is equal to I alpha. This is a relation of torque is equal to I alpha. Okay, it's one of the main equation. Okay, next, angular momentum is equal to I times of omega. So linear momentum times of radius, linear momentum is mv. So v is equal to omega r, just you substitute in this. Okay, omega r, so mr square will be the inertia. So I omega will have angular acceleration, angular momentum. Okay, next concept we are going to do, work done is equal to force into displacement, Fs. In rotation motion, torque times of d theta. Okay, power is work done by time. So displacement by time will have velocity Fv, power is Fv. In rotation motion, power is equal to torque times of omega. Same method. Theta by t will be omega, angular velocity. Okay. Next, kinetic energy of mv square we can take it. Mass is in rotation motion inertia, v is equal to omega. Okay. So like this we will get of I omega square. If you want proof, we have mv is equal to omega times of r, omega square r square. Mr square is called inertia. So mr square if you are making separately, you will get as this together will be give as inertia. So I omega square kinetic energy. Okay. Next thing, equation of motion. This is a normal equation of motion. This is a rotation motion, just as direct comparison only. Okay, just I changed the term. Thank you for watching my channel. If you like my channel, please subscribe. If you want more video, you can please comment. And if you like if you want more video, you can go and see my playlist. Thank you.